this will help me. If you notice it turn off for some reason, just let me know. Cool. All right. So very first thing, and this is sort of a side note, but it's kind of important. Does anybody know the shortcut to do that? Somebody know what I mean by that? There's a shortcut besides, I mean, traditionally you'd have to do this. Foil and do it again. And can you imagine if this was the 7th power? And that's where I go to my teacher, this is busy work, what the hell did I do to you? Right? Does anybody know the shortcut to this? Yes?
That one, if you do the a plus b times a squared minus ab plus b squared.
Oh, you're thinking about difference of cubes,
yes.
Or something like that, yeah. So that's not what this is going to be. Yeah. Anybody else have a guess? Yeah.
I believe a cubed minus b cubed formula.
Now be careful. This is not, you can't just distribute the cube through, right? This is very different from this. These are not the same thing. Cool? This, I would agree with you. You would factor like what I could say, the little dude and the big dude.
Yeah.
Remember that stuff? However you were taught? I don't know. The little dude's the little dude, so you can only fit one of each. Bam, bam. The big dude's all right with the other two. The other two ones is one. And then the middle term will always be opposite sign, product of these. And that's that. That's different. That's not what I'm talking about. I'm talking about, this is very interesting. Has anybody ever seen this here? You guys see that pattern? What's going on there?
Isn't that the binomial theorem?
Yes, it's related to, this is Pascal's triangle, which gets fed into the binomial theorem. If you know binomial theorem, you've probably seen the shortcut for this.
Yeah, but I don't remember.
Okay. I got you. Doesn't seem long to leak out. Yeah, so if you do this by hand, you'll get it. This is if I square something. And real quick check. X minus 1 plus 2x plus 1 squared would be x squared plus 2x plus 1, right? What are the coefficients of that? 1, 2, 1. So if you cube something, the coefficients will be 1, 3, 3, 1. So here's the cool thing about this. What you'll do is, it starts off with the most x's you can, and it's got a coefficient of 1. Then you get 1 less x, and 1 more negative 1, and it's got a coefficient of 3. Then you have 1 less x. So here I had no negative 1s, 3 x's. Here I have 2 x's, 1 negative 1. Here I have 1 x, 2 negative 1s, which makes it plus. And what's the coefficient here? 3. And finally I'm going to have no x's and 3 negative 1s, which makes it minus 1. Now is that, if anybody did that by hand, is that what you get? Hopefully so. Okay. So this is called, this is one application of the binomial theorem. Okay. How important is it for you to know that right now? Not crazy important, but any shortcut you can start to develop now based on very nuts and bolts, just attack a problem and work it out. It would take forever if I put an 8 there, right? It would take us forever to do that by multiplying. But if I put an 8 there, all I have to do is continue this pattern down to the row I need, and then just build it the way we just did. Very quick. Maybe. Some guys are like, that's nice, move on. You said it was optional. Good.
What would be the next step after that one? 4, 6, 8, 4?
Yeah, 1 and 4 is 5. 4 and 6 is 10. 6 and 4 is 10. 4 and 1 is 5, and then you put a 1 on the outside. So the 1s just kind of cascade on the outside, and then inside you just add the 2 above to get that next one. This is also related to the Fibonacci If you go with certain diagonals, you can get the Fibonacci numbers. Anybody know what Fibonacci sequence is? It's related to so many things. It's insane. It's related to what we as humans find aesthetically pleasing, believe it or not. Some purely mathematical sequence of numbers relates to what we as humans find aesthetically pleasing. That's awesome. So Google Fibonacci. Yeah.
Good review. Could you just explain that one more time?
So these two pieces, I see this as x and -1. So you start off with the most of these, 3 of these, and none of those. And the coefficient is a 1. Then I get 2 of these and 1 of those. So it kind of starts like that. Here's all the x's, no -1s. 2 x's, 1 -1. Like that, stepping up and down. And that's exactly what would happen as you do all the multiplications, right? Okay, cool. All right. But especially if you're going a lot further in math, now is the time to try to develop some of these shortcuts, to get familiar with them. I'm going to try to interject what I can. I'm always going to tell you it's kind of optional. If this is your last class you have to take for your major, you might not be terribly interested in any of these optional things I'm talking about. If you're going a lot further in math, you should be crazy interested in some of these things I'm talking about. Let's see. How about factoring? Let me give you a problem real quick. You guys try this out. This is one we just talked about a little bit. Try to factor that. Little dude, big dude. So what form is this in from the beginning? What form is this in? Is it squares? Is it trial and error? Is it master product, if you know that? What form is this in? How many parts can you break everything up into? Yeah, it's cubes, because you can break everything into 3 parts. 8 is 2 times 2 times 2, so forth. Everything is, you can cut it into 3. I know it's not as squares, because 27 screws it up right there. If it was 25, great. 27 sucks as far as squares is concerned. This is 2x, 2x, 2x. This is 3w squared, 3w squared, 3w squared. Cool. And then you just put 1 of each in the little dude, 2 of each in the big dude. And the part that people always forget is the poor little middle term. Right? The middle term is the most important guy in there. He cleans up all the shit you don't want. So what goes on the little dude would be 2x plus 3w squared. So then here you could put the other 2 of those, so that overall you end up with 3 of each, like you're supposed to have. Yeah, so 4x squared. At the end, you'll put the other 2 of those, 9w4. Is there another seat over there real quick? Any more seats? There you go, Angel. And in the middle, yeah, I mean opposite sign so it can cancel. And real quick, I don't know if you guys remember this, I get my 8x cubed, I get my 27w6, that's awesome. But I also get this freaking 12w squared x squared. I don't want that. So if I put minus the product of these, here I get my 12w squared x squared. I don't want that. And when I include this guy, I get 12w squared x squared negative. So it cancels that out. You guys semi with me? Does this sound familiar? I don't like that absence of a response. It sucks. Right, so here I get 18w4x. Do I want 18w4x? So thank God this is negative 18w4x. It kills that. So the middle dude is the cancellation dude. He's the cleanup guy. 1 and 2 makes 3. 1 and 2 makes 3. Oh shit, clean up the other stuff. Not really a song to remember it, but oh well. Okay. The only difference if this would have been a minus, what would have been different? Yeah, that would have been minus, and that would have been a plus. There's always one negative in the whole thing. It's either there or it's there. Cool. So I get my Math 281 students come up to me. They're upset at me because I put this problem somewhere involved in their test or something. Just go away from it. You've got to know your factor. You've got to know your factor. It's crazy important. What about this here problem? So cubes are always people's probably the most hated factoring problem. The second most hated is the one where the first number is not a 1 and you can't factor it out. So this has been given a lot of different names. There's the master product approach, which is just a reorganization of what most things are anyway. There's my approach, which is called the Surefire Method. I don't know if you guys ever heard of that. I didn't name it. What's the first step here? Almost no matter which way you want to go. Yeah, take an X out. So at this level, you guys, maybe some of you guys have developed a trial and error that kind of works well for you. So you can pretty much know that the 4 could be 2 and 2, or it could be 4 and 1, and then you just kind of match it with the factors of 6 until you get the middle term to work out correctly. That's trial and error. So if you got that and you feel pretty comfortable at it working, awesome. If you don't have something like that, and this is why it's called Surefire Method, because the process will work. If it's factorable, the process will always work. It's silly. So let's see if this sounds familiar to anybody. Multiply these guys. 4 and the negative 6.
3 with 8.
11. You find factors of it that add to be the middle term, which is actually the same thing you would do if that 4 wasn't there. You would find factors of 1 times 6 that equal the middle term. So factors of negative 24 that make negative 5 Of course, the 8 has to be negative. And then the whole purpose behind this method is to make the 3 terms into 4. Because if you have 4 terms, what method can you use? Grouping. And grouping is the easiest method there is. It's just a couple of GCFs. Right? So all you do now is you rewrite the middle using these 2 numbers as coefficients. And now you just group them. You're guaranteed it'll work. If you can find these numbers here, this grouping will work. Cool. So hopefully this is not overly amazing to anybody. If you have a different way that you do this problem, trial and error, or even something else entirely, that's fine. Has anybody ever heard of something called, this is a factoring method, something called a bottoms-up method? Okay. I don't like it. What I always tell my students is, if you can explain to me why it works, I'll let you use it. If you can't explain to me why it works, don't use it.
I learned that way from Mr. Orr taught me and started to a lot of stuff. I like this one.
Cool. And the reason, the bottoms-up method, I'm not going to show it to you. I think you should get that impression from what I just said. It hides the math it does. It's sort of, you do one little thing and then everything kind of just falls into place. And it sounds nice, and if you totally understand everything, it's a nice, quick way to do it. But people don't learn any math from it. You know what I mean? I always want people to learn some, or just to keep improving their number skill, their number sense. And that doesn't do any of that method. So don't use it unless you can write me up a little essay as to why it works. And so the last couple steps here, take out a 4x, and a 3, and then you get that. So if you got there a different way, it's not the bottoms-up method, it's something else, cool. Use it. When I grade your work, I'll go, wow, I've never seen that before, or whatever, and I might start teaching it. Okay, I'll show you one more thing that normally is something that people have forgotten, and then I want to unleash you on this little group work assignment. Let's see. Yeah.
So how do we know, like, when do we have to stop? Like,
So here the question was just to factor this. If this was equal to 0, then you have to keep going and find out what x could be. The mistake a lot of students make, and I'm glad you said that, is they'll set everything in the world equal to 0, which is kind of oblique. I think it's kind of depressing. But when students learn equals 0, they just want everything, because then they get answers. Give me answers. And you can't get answers to this, because I don't know what the hell this is. So all you can do here is rewrite it in a different format and stop. If it would have been equal to 0, you better keep going and give me answers. Yeah. Cool. Okay. Everybody see that? Go ahead and solve this math. And this is, make sure you guys see, this is not 213, this is absolute value symbols, right? There's really two main ways to do this problem, and they're both again, effectively the same. It just brings negatives in at different stages. So the way I always teach it is to first isolate the absolute value. Because it kind of goes along with what we do. If I had a problem like square root of x minus 1 plus 4 equals 7, you would first isolate the radical. Sort of like you're in charge of a country. You want to isolate the radical elements and then kill them. So it kind of goes along with that idea of isolating where my x is stuck and then doing something from there. You could also just replace this with the two options. So does everybody understand? What is the absolute value of x? It's a roughly trick question because there is not one answer. Yeah, it's either x if x is greater than 0 or equal, negative x if x is less than 0. All this says is if the number is negative, it has to change the sign of that number, of course. The absolute value doesn't do just one thing, it does two. It's based on what the number is. It either makes it positive or it leaves it alone if it's already positive. Or 0. So here, if you add 7 and divide by 2, you get there. Is that cool? And then the absolute value of what is 1? 1 or negative 1. So then that could be 1 or that could be negative 1. And then you solve those two equations, right? So there's always got to be two cases somehow with absolute values. Absolute value inequalities get a little bit more interesting, right? So then you get 2 or 4/3.
Negative?
Negative? No. Because when you add 5 over, it becomes positive 4. Okay. So any other questions real quick? So here's what's going to happen, I think. So today I'm going to give you this problem. I'm going to give you this sheet. I'm going to put up here the exact problems I want you to do. Because a few of these have A through J or whatever. I don't want to take that much time. Today we're probably going to get out of here decently early. Do not get used to that. What I really hope is going to happen possibly is you desperately need to get into Chapter 1 and you desperately need to start doing the homework so you can identify your weak spots. So next class, I really want to spend a lot of time on what are your questions from the first Chapter 1 assignment. So I can really figure out what to go back and cover. So next time, I'm going to try to close Chapter 1 off. Just figure out where we have a weak spot, let's talk about it, and then move into Chapter 2. That's my plan for next Wednesday. So for this coming Wednesday, I need you to get into Chapter 1 homework then to do that. So I'm really worried I don't have enough of these. So like I said earlier, unless you really, really, really do not like working in groups, you can work as one, a wolf pack of one. But I really kind of want you to work together in groups. Another reason is because a lot of you guys don't have the book, and I don't think I have enough copies of this for every single person in here. So let me start in the back row. And you're right, the international one always does slightly different. If you guys put together, I'll give you a copy, so between the three of you guys, you got the right block from there. You two there? write that up on the website.
So the first one's gonna be a
Yeah, now
plus.
let's see, 3 want to work, or somebody wants to go below. Let's do you two here. You guys here. I guess I don't need to tape this. This is